Hello everyone. Today we're gonna talk everything about the binary coding. What's the difference between the binary coding and the decimal? So there would be times that I would use like some French term or so bear with me. Okay, we'll start from binary. What's binary? We have a language in our when we speak in everyday, we have a language, and we use in our language our number-based system is 1 2 3 or decimal. It's until 9, 0 until 9. Okay, and it repeats every time that we would go up, even if we would go like 325, for example. This one is this is stage 0 to 9, this one also 0 to 9, and this one also 0 to 9. So that's the decimal counting system that we are using. But computers and other digital devices don't understand this language. They just understand the language of existing or not existing, or true or false, or 0 and 1, 0 being false and 1 being true. So okay, so in binary system we are using these 0 and 1s, and whenever we are sending and receiving data, they're usually in the form of a signal or a discrete signal that would be high and low. And of course there's the noise in this signal that you would have noise in here, and we normally would try to, if this would be the axis of the signal, we would normally try to get a limitation in here. That limitation would be for example in here we would use resistors to limit the current, and we would look at two places. So we are looking in here. If it doesn't exist, it would be a 0, and if it exists, the signal exists, so it's a 1. This side would be the voltage, yeah, and this side would be the time. Okay, this axis voltage and this axis time. So yeah, this way you would know that this is 0, this is 1, this is 0, this is 1. So the machines use that to understand which is 0 and which is 1. We have already created a system for this that the machine would understand, and for this machine we have already created the number system that it could count and understand any number from being 0 until infinity, or also the minus or minus infinity. So this system was invented by George Boole, I think, in 1850 something, 1850 until 1864, something like that. That's, we call it the Boolean form, and we have also algebra for this, which is called the Boolean algebra. So for example, if you would have a number in 11, if you would want to present it in Boolean form, it would be 1 0 1 1. In here we have names for these limits or extremes of these number, all the Boolean numbers. This one would be MSB, this one would be LSB. I started from this lesson is from absolute zero, or like from I would say the base of the Boolean algebra. So in here, MSB, which is the most significant bit, and LSB would be the least significant bit. Okay, so in here, for example, and when we are doing, I would say, in the positive direction, 0 to infinity, we are representing these numbers and these I would say cells by to the power of x. In here, for example, LSB is normally to the power of 0 to the power of 0, and it would go until MSB, which whatever it could be. It depends on the message we are sending and the protocol that we are using, that device. So in here, for example, in here we have 1 0 1 1, this being to the power of 0, this being to the power of 1, 2 to the power of 2, and 2 to the power of 3, to the power of 3. So in here we know 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, and 2 to the power of 3 is 8. And in here, first of all, we would look which one of these does exist. So this one exists, this one exists, and this one is a 0, so it doesn't exist. We don't count this one. Okay, so we add this one to the power of 3 would be 8, plus 2 to the power of 2 to the power of 2 is 4, but it's a 0, so we don't count it. 2 to the power of 1 being a 2, plus 2 to the power of 0 being a 1. So when we would add that, it would be 11, the way we told earlier. So after that, we have a truth table. In truth table, for example, in here we have a truth table of 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 and 1 0 1 until the end. So in here we have entries, and we have an exit. Almost always, I would say always, the left side is the entry and the right side is the exit. Okay, in the truth table we would have, like for example here we have 0 1 2 3 4, but sometimes there's x or the null or doesn't exist. Wow, yeah. So these two also could be in here when we use it, and why we use it. When we are using this, when this bit or this result or this exit is not important, so we are using one of these. And it's very important when we are doing the schematics, and we are want to use the Carnot table to write down the logic circuit. So it's very important to sometimes to ignore these are the exits that we ignore, and they are not important for us. Okay, and we also have the